In this video, we're going to talk about the behavioral pattern known as a template method. So the intent here is we want to try to define the skeleton of a particular algorithm, but essentially leave parts of it open for implementation. So the template method lets a subclass essentially kind of redefine or change or override pieces of the algorithm without changing the whole algorithmic structure. So if we want to think about like an application may have documents. The application class is responsible for essentially opening documents stored in some format, whatever that is, but it should be stored in a file, and it may have some structure to it. So for example, we might have code that looks kind of like this, right? So open document takes a file name, right? And if I can't, then obviously there's some problems, just return. Otherwise, I call do create document, and if that works, if I get something back, then I can add that document to my list of documents, add to the about to open document, essentially call some function. We can call open on the document, call do read on the document, and so on, right? So, when we call this is a template method. And the reason is because it's outlining a very specific algorithm, very specific set of steps, but it's allowing the subtypes or the subclasses to change all the different pieces. And if we want to, we can make this an abstract template. So we can actually make parts of it literally abstract. So for example, here, the about to open document could be an abstract function. And what that would do is force everybody that inherits from the class to actually implement that function and decide, what should I do when we're about to open the documents? Or we can provide default behavior and just let people override and decide what to do. So the applicability is, we want to implement the invariant parts of the algorithm once, and then leave the variant parts up to the subclasses to implement. When we want essentially common behavior among all the subclasses. So what we're doing is kind of saying, there's like 10 different ways that we could maybe open a file. But if you look at the 10 ways, like 80% of their implementation is actually the same. So, hey, this is how we can actually pull that common code out and generalize it. So we can basically turn things into a template method and then allow the concrete subclass to change the specific part it needs to. So basically, you kind of define these methods that we call hooks, and we define them at very specific points and allow other people to extend the algorithm and control essentially what happens at those different points. But we can choose where those points happen, right? So that's some of the flexibility here. So the structure is we should have some sort of abstract class. Usually it's abstract. Technically it doesn't have to be. And this should define, essentially the primitive operations that the concrete subclass would be overriding, and it can define those as abstract, or it could maybe give a default and then just let them override, and then maybe certain parts of it we actually don't allow them to override. So you can actually mark certain pieces or certain functions as, depends on the language, but things like sealed or final or something like that, and basically say, my subclass, you're not allowed to override some operation. And then the concrete class goes in and provides anything that's been marked abstract and overrides anything else that it needs to. So the consequences here, when we think about template methods, they're actually one of the fundamental ways we get code reuse. It's usually really useful if you have class libraries, because the idea is you want to provide the common behavior and then let people specialize it in a certain way. It does tend to kind of create this inverted control structure that's been sometimes referred to as, the Hollywood principle, which is, don't call us, we'll call you. This refers to how the parent class actually calls the operations of the subclass. Right? So typically when you implement code, you implement your class and you usually look at that class and you call your super, right? So you actually call the things you inherited from. In this case, we're actually literally saying, here's an abstract function, I'm going to call it, which means I'm actually calling something in my subtype. So it's inverted from the way we would typically think about it. So it's very important, though, that the templates specify which things are hooks, right, which might be overridden, and which are abstract operations, which must be overridden. And And that's very important, right? Because you want to force your subtypes to override the things that must be overridden. And that's why typically you would mark that function as literally abstract. Whereas hooks, you might provide a default, which does maybe it does something, or maybe it's just an empty method. But either way, you would provide it, and that doesn't force the subtype to actually override.